Understanding the difference between synchronous and asynchronous programming. Synchronous programming, a step-by-step approach. In synchronous programming, tasks are executed sequentially. Each operation must complete before the next one begins, resulting in a linear flow of execution. This can be intuitive for developers, as the order of operations matches the program's written code. However, synchronous programming can lead to inefficiencies, particularly when dealing with time-consuming tasks like file I/O or network calls. During these operations, the entire program may become unresponsive, waiting for the current task to finish. Asynchronous programming, our non-blocking model. Asynchronous programming, on the other hand, allows tasks to run concurrently. Instead of waiting for an operation to complete, the program can initiate a task and then move on to the next one. When the asynchronous task finishes, it typically triggers a callback function or returns a promise, allowing the program to handle the result without blocking further execution. This model is especially beneficial in environments where responsiveness is crucial, such as web applications. Advantages of synchronous programming. Synchronous programming is often simpler to implement and understand, especially for straightforward applications. The linear flow makes debugging easier, as developers can follow the code execution step by step. Additionally, when tasks are executed in sequence, data integrity is often maintained more easily, as there's no risk of data being altered by concurrent operations. Advantages of asynchronous programming. Asynchronous programming excels in handling tasks that involve waiting, such as network requests or file I/O. By allowing other operations to run while waiting for a task to complete, it improves application performance and responsiveness. This approach is particularly valuable in web development, where user experience can suffer if the interface freezes while waiting for data. Challenges of synchronous programming. One of the main challenges of synchronous programming is its inefficiency when dealing with I/O-bound tasks. Since the program halts until each task finishes, it can lead to significant delays, making it unsuitable for applications that require real-time interaction. This model can also lead to complex error handling, as any failure in a task can affect the entire execution flow. Challenges of asynchronous programming. While asynchronous programming provides many benefits, it also introduces complexities. Callback hell, where multiple nested callbacks make code difficult to read and maintain, is a common issue. Additionally, managing asynchronous flows and handling errors can be more challenging compared to synchronous code. Developers must adopt best practices and use tools like promises and async, await syntax to mitigate these issues. Conclusion: choosing the right approach. The choice between synchronous and asynchronous programming largely depends on the application requirements. For simple tasks or applications where sequential execution is preferred, synchronous programming may be adequate. However, for applications that require high responsiveness and efficiency, especially those involving I/O operations, asynchronous programming is often the better choice. Understanding the strengths and weaknesses of each approach will help developers make informed decisions when designing their software solutions.